Hi students, today we are going to understand a very important concept in physics based on oscillations. Now we have studied the oscillations of a simple pendulum both in the theory class as well as practicals. Now what are all the different types of oscillations we have studied? So today we are going to experience them with the help of a teaching aid. So the different types of oscillations are what? Free oscillations. Okay. Next is damped oscillations. And next is maintained oscillations. Okay. And then is forced oscillations. Lastly, resonant oscillations or resonance. Very interesting topic. Okay, now you all can see that a mass is attached to the free end of a string and another end of the string is attached here at the point of suspension. So this system is called as a simple pendulum. Okay. Now when the simple pendulum is undisturbed or at rest, it is said to be in equilibrium position or mean position. Okay. Now I displace the pendulum to one extreme position. Okay. So this is one extreme position. Say it is left for the pendulum. Okay. From here I drop it. So it is now going to oscillate to and fro, to fro, to fro. This type of motion only is called as what? Oscillatory motion. And you can see that it is having a definite time taken to complete one to and fro motion, that is called the period of oscillation. Okay. So how much time it takes to go onward and return, the total time only is called as the period of oscillation. And suppose if L is the length of the string, okay, and G is the acceleration due to gravity in this place, then the frequency of oscillation is given by nu naught is equal to 1 by 2 pi into square root of G by L. And the reciprocal of this frequency is called as what? Time period. 2 pi root L by G we have studied. Now for the given shape, for the given geometry of the oscillating system, this system is having a natural frequency. That natural frequency only is denoted by the symbol nu naught. So if it is taken to another room or anywhere on the same surface, then it will have the same natural frequency and its oscillation only is called as natural oscillations or free oscillations. You imagine if there is no air inside this room, means permanently the pendulum will be oscillating non-stop perpetually. But actually now what is present inside this room is air, isn't it? So because of that air, what is going to happen after a duration of a time? Let us see now. So in the presence of dense air inside this room, now once again let us take to an extreme position and leave it. Okay. So you can see that at the end to end, the amplitude of oscillation continuously decreases. Can you all feel that the amplitude of oscillation decreases and more towards the mean position it is now shrunk, isn't it? Amplitude has it minimized. What is the reason for this? What is the reason why it should reduce its amplitude? This is because the medium surrounding this pendulum is exerting some force, opposing force. That opposing force exerted by the medium surrounding the oscillating body is called as damping force. Damping force. So air, water, oil, these are the medium, okay, which can exert the damping force in the form of viscosity. So because of that, this oscillating system is losing some energy. Understand? In the absence of this medium, it should continue to oscillate permanently. I told you. Why? Because there is no damping force. In the absence of damping force, its amplitude, its energy and frequency all will remain constant. But in the presence of damping force, what is happening? The system is losing the energy. As a result, it loses the amplitude of oscillation. So such oscillations in the presence of the external damping force is called as damped oscillation. So in the damped oscillation, now you can see here the amplitude continuously decreases. So the amplitude or the height of the wave, okay, can you see that this is the amplitude continuously decreases. How means exponentially. It is like radioactive curve, is it not? So exponential decrease in the amplitude. Also the energy decreases. Okay, so this is a graph drawn between amplitude and time, or energy versus time. Understand that? So both the energy and amplitude decreases exponentially with time. Okay, now I do not want the system to lose energy. Okay, I do not want the system to lose energy. I want to maintain the amplitude always constant, even in the presence of an external medium. Then what I should do? I should compensate the loss of energy. Is it not? Suppose if a mud pot is kept below a water tap and it is fully filled with water. Pot is fully filled with water. Now tap is closed. Okay. So a fully filled pot is kept below a tap which is closed. Now a small hole is made at the bottom of the water pot. So water starts leaking. At the same time, if I open the tap so that the amount of water leaving the pot is equal to the amount of water entering the pot, means always the pot will be fully filled. Is it not? The rate at which water is leaving the pot must be equal to the rate at which the water is entering the pot. Then the pot will be always filled maximum. In the same way, suppose if the system is oscillating and it loses energy, okay, so every time I am going to give energy from outside so that I can maintain the amplitude of oscillation always constant. So I am maintaining such that the amplitude of oscillation is constant. Such oscillations are called as what? Maintained oscillations or sustained oscillations. Now best example is what? When mummy is oscillating the cradle with the baby. So always she has to maintain the same oscillations. Otherwise, no, the amplitude of oscillation will slowly stop. Is it not? Decrease. Then the baby will start crying. So the mother is always constantly applying what? External energy. Okay, so that the amplitude of oscillation is maintained constant. Such oscillations are called as maintained oscillations. So in the maintained oscillations, can you see that the amplitude of oscillation remains constant? Okay, so we are supplying energy from outside the system. Okay children, now the next one is very important, that is called as forced oscillation. We are forcing, okay, the medium to oscillate with some frequency which is other than its natural frequency. So we all know that for the given length, okay, the simple pendulum is having a definite frequency of oscillation that is called as its natural frequency. Okay, not only the simple pendulum, even the civil structures like the bridges, the suspension bridges between the two hills, then the concrete bridges, then the railway track bridges, then the tall buildings, okay, multi-storied buildings and all, they all have some geometric structure, due to which they also have somewhat natural frequencies. Okay. Now we take the example of a simple pendulum whose natural frequency is fixed, that is nu naught. Now what is going to happen? You see here, I allow this pendulum to oscillate. Okay, I allow this pendulum to oscillate. Now its amplitude is continuously going to decrease. We very well know. Okay, because of the damping force exerted by the air surrounding this pendulum. But now I am going to give some force. Okay, you see here, once I have forced. Now 2 oscillations I did not touch, 3. Then after the third, once again I force it to oscillate. Then 3 oscillations I left free. Then like that for every 3 oscillation I am applying a force. So the external force is applied after every 3 oscillations. So I call the external force as a periodic force, because after every 3 oscillations I am exerting a force. Now after every 2 oscillations I am going to exert, okay, a force. So now can you see that the amplitude is picking up? So the external force which I am applying on the system is also periodic. That force which is occurring at equal intervals of time is called as a periodic force. So my dear students, you should understand that the external periodic force itself is having a frequency. How many times I pushed per second? Either twice or thrice or every time. See, every time I am going to hit the bob. You see here, once, again, 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 again. Can you see that the frequency of the force applied on the system is increasing or not? Every time I apply a force, is it not? So, the external periodic force is also having a frequency. So now this system will forget its original frequency. The body cannot vibrate with its original frequency. Then how it will vibrate? It is forced to vibrate with the frequency of the external periodic force. So body is now not going to oscillate with its natural frequency nu naught. It is forced to oscillate with whose frequency? With the frequency of the external periodic force. Such oscillations are called as forced oscillations. Sometimes practically you think in a home, okay, father will be having some idea of constructing a house within a budget, okay, 10 lakh for example, 20 lakh let us say. But mother will be having some other dreams and father will be forced to vibrate according to the tunes of the mother. Is it not? Physics is everywhere. So, our idea is different, but according to our idea, we are not performing the job. According to the tunes of some other person, if you do the job, definitely the job will be different from its original nature. Is it not like that? The body is having a definite frequency called its natural frequency, but the body is unable to oscillate with its original frequency, but forced to oscillate with some other frequency that is equal to the frequency of the external periodic force. That is why now the external force which is used to oscillate the system is called driver. It is driving the system. It is driving. The external periodic force is going to drive the system. That is why the external periodic force is called as the driver. Okay, who is driven by the force? The system. The system is getting what name now? The driven. Understand? So, such oscillations of a system, okay, with the frequency of the external periodic force, okay, which is other than the natural frequency of the system. That is very important. Now, the last is very important, that is called as resonant oscillations. I told you that when the system is oscillating, you observe keenly now. So, once I hit, then twice I leave it, okay, then next I hit, twice I leave it, like that. Now, suppose if the external periodic force is having a frequency equal to that of the natural frequency of the system, we have to take care. See, I told you that the number of beats per second or the number of intervals the ball is hit per second is different, I told you. By chance, if the external force, that is if the external frequency of the periodic force matches with the natural frequency of the system, okay, now what is going to happen? See, the external periodic force is having a frequency. Now, if it happens to be equal to that of the oscillating system, then the amplitude of oscillation will be very large. The amplitude of oscillation will be very large. You can observe like this, okay. So, such oscillations only is called as what? Resonant oscillations. So, when is the oscillation said to be resonant oscillation? When the frequency of the external periodic force is equal to the natural frequency of the system. Sometimes it is advantageous for us in some applications, whereas in some other applications it is very dangerous also. Understand? It is hazardous. Now, for example, While the construction of an aircraft, the engineers should take a concern of the length of the wing, the geometrical size of the wing, because the geometrical size of the wing also is having some natural frequency. When the turbojet engine of the flight is vibrating with a certain frequency, that should not match with any of the natural frequencies of the wings. Then what will happen? The amplitude of oscillation of the wing will vibrate with a very high amplitude, is it not? So that it may collapse. So this is one application where this is disastrous. Resonant oscillation is disastrous. Now one more information is in nature, sometimes hurricanes, wind storm, dust storm, they will go and hit with the concrete structures such as the building and the bridge. So the wind is also having a frequency. Suppose if it matches with the natural frequency of any bridge means, then the bridge may collapse. Like that, during earthquake, all the buildings will not fall down. Only certain buildings. See, there are some short buildings, tall buildings and medium height buildings and all. When the tremor or the shock waves are passing below the earth, okay. Now what is happening? The seismic or the shock waves created by the earthquake is having some frequency. That is the external periodic force. And the natural frequency of the building is matching with this external periodic frequency, means such building which satisfies this condition only will collapse. So these are all some of the disastrous applications. This is also the reason why soldiers are asked not to do march past on the river bridges connecting the two hills. Why? Because when they say left, right, or left, right, left, right, left, right, left, right, like that, the time interval between the left and right decides the frequency of the march past. If the frequency of the march past, which is the external periodic force, matches with the natural frequency of the bridge, means the bridge will collapse. This is the reason why soldiers are advised not to do march past on the bridges. So these are all some disastrous applications. Now what are all the useful applications of the resonance? Now we are having the remote control to tune the TV channels or the radio channels we can tune, is it not? What is used for the tuning of these radio stations and TV stations? Inside the TV set and radio set, there is a circuit called as LCR circuit, which is made up of inductance coil, capacitor and resistors. Okay, out of this, no, the inductance and the resistance of the circuit will be fixed, while the capacitance is made to change. Okay, so that the resonant frequency, the frequency of a particular radio station can be tuned inside the set. So in such cases, this resonance is useful to us. Okay, so my dear students, what are all the different type of oscillations we have studied? First one is free oscillations. In free oscillations, the amplitude, frequency and energy all are constants. Okay, and the natural frequency depends on the geometry of the oscillating system. For example, for a simple pendulum, the natural frequency is given by nu naught is equal to 1 by 2 pi into square root of G by L. In the case of a vertically loaded spring, okay, which is oscillating vertically, its natural frequency is given by what? Nu naught equal to 1 by 2 pi into square root of K by M, where K is called as the spring factor, force constant, and M is called mass or inertial factor. Okay. Now damped oscillations. I told you that in the presence of a medium such as air or water or oil, if the pendulum or any system is oscillating, means then with time the amplitude of oscillation continuously decreases. Consequently, the energy also continuously decreases, and this decreases exponentially with time. Understand? So this type of oscillations are called as damped oscillations. Okay, and the viscous medium such as air, water and oil, which exert the opposing force, they are called as damping forces. Okay. Now third type of oscillations are called as maintained oscillations. So what's the other name of it? Is sustained oscillations. So here we want to maintain the amplitude of oscillation as constant. How? by supplying energy from outside source. For example, you take electrically maintained tuning fork which is used in Mills string experiment. Then the moving coil galvanometer, the oscillation of the coil will be damped for measuring the very feeble currents. So here the rate at which the energy is lost by the system is counterbalanced by supplying energy from outside at the same rate. The fourth type of oscillations are called as what? Forced oscillations. So from the name itself, we are forcing a system to oscillate with any other frequency different from its natural frequency. Okay, so here frequency of external periodic force, which is called as driver, is denoted by nu suffix d, and the body oscillates with the frequency nu d. Therefore, it is called as the driven. Oscillating system is called as the driven. Now, the resonant oscillations particularly, what is it? In this frequency of the external periodic force is equal to the natural frequency of the oscillating body. So, nu d is equal to the natural frequency nu naught. And here the amplitude of oscillation is a maximum. Okay, so disaster, sometimes it will be advantageous and sometimes it will be disastrous also. Okay, anyhow, these are all the different types of oscillations. I hope you must have understood well. Fine.